Hello guys, how are you today? So today I'll be explaining the math AMS of term 1 week 4. So let's get started. Given that x is greater than 0 and y is greater than 0, meaning they cannot be negative and they cannot be 0, which of the following is equivalent to the given expression? So in my opinion, I will take out the value and I will simplify it. So we have 4x y to the power of 3 plus 16x squared y squared. Now, we start with the numbers. Which number is the least common or the greatest common factor, the greatest common factor in between 4 and 16? In this case, it's 4. So we will take 4 outside of the equation. Now, between x and x squared, which one is more abundant, which one has the less exponent? In this case, it is x, so we will take x outside of the equation. In between y to the power of 3 and y squared, which one has the less exponent? It is y squared, so we will take it out of the equation. What do I mean by taking it out of the equation? Now, I will demonstrate an example. Let me just erase these. Okay, we took out 4. 4 divided by 4 is 1, so what's left here? 1. X divided by x is 1, so it's also 1 again. Y3 divided by y2 is y. Plus 16 divided by 4 is 4. X squared divided by x is x. And then y squared divided by y is 1. So you can remove everything multiplied by 1, all the multiplication by 1, and you will be left with what? You will be left with y plus 4x. Now this is all under what? This is all under the radical. So we take out the ones that we can take out of the radical. So what is the square root of 4? It is 2. Square root of x, we cannot take it out. And then square root of y squared is y. So it's 2y outside. And then we have the radical. What remains? X times y plus 4x. Distribute the x, so it will become xy plus 4x squared. So this over here is what this is our final answer. We move on to question number 2. Which of the following is the result of subtracting gx from fx? Okay, you have to pay attention to the wording. Gx from fx, that means it's fx minus gx. Okay, so what does it mean? It means 2x3 minus 3x2 plus 2x. You subtract gx, so you have to change the sign of every single one of them. So minus x squared plus x minus 2. So minus x squared plus x minus 2. What do we get in this scenario? In this scenario, we get 2x to the power of 3 minus 4x squared plus 3x minus 2. So our answer is this one over here. Now, we move on to question number 3. Fill in the blanks with the correct numbers. Now, if you notice later on in part C, you will see that they are helping us by making us do part A and part B. First of all, what happens in part A? They want the coefficient of x squared in the expansion of 2 minus x to the power of 7. So this is our A, this is our B, and we need to find what? We need to find x squared, which has x, A or B or both of them. In this case, B only has x. So what does it mean? It means you're gonna first start with the combination 7, then you have 2, which is A, multiplied by minus x. Now, they want it to the power of 2, so you will have to raise it to which power? To the power of 2. If this is to the power of 2, what will be for this? For this, it will be 7 minus 2, which is 5. So now the combination is what? The combination is 7, 2, because you always take the exponent of the b, okay? So now we have what? We have 7 combination 2 times 2 to the power of 5 times minus x squared. So now you guys are supposed to know how to do this, okay? After doing it on the calculator, you're supposed to get an answer, which is 672. We'll move on to part B. What does it say in part B? We need x3 and we have what? We have A, we have B, and we need x to the power of 3. Which of them has x, A or B? In this scenario, B has x. So we'll start with the combination 7. We don't know what the combination is. 2, and then minus x to which power? To the power of 3. So if this is to the power of 3, then this is to the power of 4, because 7 minus 3. And then, so it's going to be 7 combination 3, because in this case, it will be combined with the exponent of b. So after doing it on the calculator, you guys should know how to do it on the calculator by now, because we practiced so many times. You're going to get an answer of what? Of minus 560. Now we move on to the next part, which is the most important part. The coefficient of x to the power of 3 in the expansion of this. So this is a really important part. And now, when we're solving, you will notice why they made us do A and B. So there are two ways in this expansion in order to get x to the power of 3. The first way is to directly solve this by doing the combination. So it's going to be what? 7 combination 3 times 2 to the power of 4 times minus x to the power of 3. This is the first way. And the second way of doing this is what? Is taking the combination as x to the power of 2, but then multiplying by this x, and we will get to the power of 3. So we will do the combination of x to the power of 2. So it's 7 combination 2, 2 to the power of 5 minus x to the power of 2. Okay, multiplied by what? Multiplied by 3x. Why? Because we need it to be x to the power of 3. Now, if you solve both cases, for this one, you're going to get 2016 x to the power of 3. Because I'm going to let you guys solve it on your own. If I solve it, it's going to take too much time. And plus, you need to practice how to solve. And if you solve this one, which we already solved this from before, minus 560x to the power of 3. Now, because they have the same exponent, they have the same variable, we can add them together. So it's going to be 2016x to the power of 3 minus 560x to the power of 3. What do we get? We will get an answer which is what? Which is 1456x to the power of 3. There's the minus over here. So the answer over here is what? The answer over here is 1456. Now I'm just gonna get any random example. Let's say they wanted x to the power of 4. If they wanted the expansion of x to the power of 4. Again, what did we say are the two ways to do this? First way is to take it directly from the combination and get x to the power of 4. So it would be 7 combination 3, 2 to the power of 7 combination 4, 2 to the power of 3 minus x to the power of 4. So the first way is to do the combination of this. The second way is what? Is to do the combination but of x to the power of 3 and then multiplied by this to get x to the power of 4. So it will be 7 combination 3, 2 to the power of 4 minus x to the power of 3. All of this times 3x. Now, what do you do for this one? You will find the answer. Let's say this is the answer. Answer x to the power of 4. Let's say this is number 1. Answer x to the power of 4. And this would be what? Number 2. Answer x to the power of 4. Because they both have the same variable, you can add them together and you will get the final answer. Okay, so this is how we solve questions like these. Let's move on from question number 3 all the way until question number 4. Solve the given equation when a is equal to 3. In this scenario, I would just substitute, so it becomes a radical minus 2 times 3 minus x is equal to 3 times 3 minus 1. So radical minus 6 minus x is equal to 8. Now you square both sides to get rid of the radical. So minus 6 minus x is equal to 64. Move this to the other side. Minus x equals 70. So x is equal to minus 70. Perfect. Now, question number 5 is long. It's not hard, it's just long and it needs a lot of concentration. So, consider the expression 1 minus 4x to the exponent of 1 over 2. They want us to what? To expand this as far as the term in x to the power of 3. Okay, it's easy to expand. You need to do whatever combination. But we have a small issue that it's to the power of 1 over 2. It's to the power of a fraction. And like when we were discussing before, we would never mention that we would have any fraction power, any negative power. So now, look what we are going to do. If we're going to expand this, if we're going to expand any expansion to the power, this means like it's raised to the power of negative or fraction, must is underlined in red, must start with 1. So any expansion to the power of a negative or a fraction must start with 1. It's mandatory for it to start with 1. Now, in this case, it already starts with 1. What do I mean by starts with 1? I mean that the a is equal to 1. So always, if it's to the power of negative or fraction, our a needs to be 1. It's very important. So now that in this scenario our a is 1, look how we're gonna solve. First thing we're gonna do is we're gonna write the combination. But you start combination 1 over 2, you start always with, and we start with whole number 1 over 2 combination 0. This is the first combination. Multiplied by our a, which is 1, times our b, which is minus 4x. Right? Then we add 1 over 2 combination 1 times minus 4x. Remember, it's combination a times b, combination a times b, plus 1 over 2 combination 2 times 1 times minus 4x, and then finally, last but not least, plus 1 over 2 combination 3 times 1 times combination minus 4, sorry, not combination, times 1 times minus 4x. Now, regarding the exponent, remember what we said with 1. From 1, we start with the n and we decrease all the way. But in this case, our n is 1 over 2. So it's going to be very hard for us to do anything with it. That is why, very importantly, that is why we need to start with 1. Why? Because 1 to the power of anything, it's 1 itself. And 1 multiplied by anything is the number itself. So you can directly remove the 1. So the reason we started with 1 was because 1 to the power of anything is 1, and it's going to make our life much easier. Okay, now the next step, we move on to b. Remember, with b, we started from 0 and we would increase until n. But in this case, we cannot increase until n, so we'll just keep on increasing the number by 1 each time, and it's going to be infinity. So you can expand this until x to the power of infinity, but we don't have that now. Now they were asking us for what? For x to the power of 3. So we start with minus 4x to the power of 0, and then minus 4x to the power of 1, minus 4x to the power of 2, minus 4x to the power of 3. Now we start. This you can replace it all with what? You can replace it all with 1. Plus 1 over 2 combination 1, this is 1 over 2, times minus 4x to the power of 1, which is basically minus 4x. So 1 over 2 times minus 4x, this will give me an answer of what? Of minus 2x. Okay? We got rid now of the first two. We'll move on to the next one. 1 over 2 combination 2. How do we do the combination here? Very, very important. First thing we will start off with is n. So 1 over 2. You always multiply by n. Then we do what? We do 1 over 2 minus 1. And we stop. As long as there are two values being multiplied, 1 and 2, there is two values being multiplied, then we stop. Because why? Our k in this case is 2. 2 factorial. If we had 3, like in this case, what would we need to do? We would need to make sure that there are 3 factors being multiplied. So it's 1 over 2 times 1 over 2 minus 1 times 1 over 2 minus 2 over what? Over 3 factorial. Now these you can put them on the calculator. If you put it on the calculator, it is what? It is 1 over 2 times 1 over 2 minus 1 over 2 factorial, and you will get what? You will get minus 1 over 8. Now remember, this is multiplied by what? This is multiplied by minus 4x squared, which is basically 16x squared. So minus 1 over 8 times 16, this is minus 2x squared. So it's minus 2x squared. Now we finished from this, we can get rid of it. Now, last but not least, we have this one. This you can put it on the calculator. So it is 1 over 2 times 1 over 2 minus 1 times 1 over 2 minus 2. As you can see, there are 3 factors being multiplied. So we stop and then we go over 3 factorial and we'll get an answer which is 1 over 16. Now, so 1 over 2 combination 3 is 1 over 16 multiplied by minus 4x to the power of 3, which is basically multiplied by minus 64x to the power of 3, which is what? Which is minus 4x to the power of 3. So minus 4x to the power of 3, we can erase all of these, and just like that, we got our final answer, which is what? Which is 1 minus 2x squared minus 4x to the power of 3. So 1 minus 2x squared minus 4x to the power of 3. Now, part B, very, very, very important. By substituting x equals 10 to the power of minus 2 in the expansion obtained in part A, find to 6 significant figures the square root of 96. So radical 96. This requires what? A lot of tricks and whatever, but in my opinion, I would look at what they want me to substitute x by. In this case, x is what? X is 10 to the power of minus 2, which is basically 1 over 100. Right? That means we have to get what? We have to get 4 over 100. And conveniently, if you do 100 minus 4, you are gonna get 96. Okay? Are you getting where I'm at? Are you getting like what I'm trying to say? So 100, 10 to the power of minus 2 is 1 over 100. Substitute it in the x, which is 4. So 100 minus 4 is conveniently 96. So what are we gonna do now? We're gonna take the radical and we're gonna write it as 100 minus 4. Now, what did we say? We said that our first term, a, always has to be what? It always has to be 1. So how do we make it 1? We make it 1 by taking away radical 100. So taking away radical 100, it's going to be 10 over here, because what's radical 100 in the end? It's 10, okay? Times radical 1 minus 4 over 100. Let me change the color, hold on. Over 100, okay? And it's all in the radical. Now, we don't forget that we can change the radical into what? We can change the radical into 1 over 2. So now this is what our equation looks like. Our equation looks like 10 times 1 minus 4 over 10 to the power of 1 over 2. Now, why did we do this like this? Why did we do it like this? Because we need to achieve this basic format. Okay, as you can see, we did achieve this format. How do we know? Because we have 1, which is our A. We have minus 4, which is minus 4, which is our B, and then we have x, which is 1 over 100, right? And again, you can write 1 over 100 as what? You can write it as 10 to the power of minus 2. So now we have what? We have 1, which is our A, minus 4, which is our B, and x, which is 10 to the power of minus 2. All of it is to the power of 1 over 2. Now, you don't need to expand. Why? Because we already expanded it before. The only thing you need to do is substitute x in these over here. So what is x in our case? In our case, x is 10 to the power of minus 2. So it's going to be 1 minus 2 times 10 to the power of minus 2 minus 2 times 10 to the power of minus 2 to the power of 2 minus 4 times 10 to the power of minus 2 to the power of 3. Okay? And so if you put it on the calculator, you can put it on the calculator to solve it. You will get an answer which is to 6 significant figures, 0.976. So 0.9, my bad, it's not 76, 0.979796. Okay, so to 6 significant figures, it's 0.979796. Now, what did we get now? We got what did we get? We got the value of 1 minus 4 times 10 to the power of minus 2 to the power of 1 over 2. However, if you remember on your scratch paper that you multiplied it by 10. Don't forget that you multiplied it by 10 because it's very important for the answer. So then you will multiply it by 10 and you will get what? You will get 9.79796. So to 6 significant figures, it's 9.79796. Okay? So that's question 5 done. Now, question 6. I believe question 6 is the longest and one of the most complex questions in this quiz. So please pay attention and focus. I'll try to explain my best. Now, what did they say? They said, expanding 1 over radical 9 plus x to the power of 2 in ascending powers of x gives us. So, before we start, we said that whenever we're dealing with an expansion and it is to the power of negative or fraction, then we will need to make our a equal to. So let us see what is the value of this power. So it's 1 over radical 9 plus x to the power of 2, which is the same as 1 over 9 plus x squared to the power of what? To the power of 1 over 2. Because the radical is the same as 1 over 2. Now, 1 over something to the power of 1 over 2. If you bring it up to the numerator, it will be what? It will be 9 plus x to the power of 2, all of it to the power of minus 1 over 2. So if you change its place, if it was in the numerator and you brought it to the denominator, it will be negative. If it was in the denominator and you brought it to the numerator, it will become negative. So as long as you change its place, whether it's up or down, it will become negative. Okay, so we are dealing with what? We are dealing with 9 plus x to the power of 2, all of it to the power of minus 1 over 2. Let me just clear these so we can have more space. Now, we said if it's to the power of negative or fraction, in this case it's both, we need to make our a equal to 1. So how do we make our a equal to 1? Very simply, we will need to take out what? We will need to take out the 9. So it's going to be what? It's going to be 9 to the power of minus 1 over 2, okay, times what? 9 over 9 is 1, okay, plus x squared over 9. So we took out the 9, that means you have to divide the full thing. So 9 to the power of minus 1 over 2 times 1 plus x to the power of 2 over 9 to the power of minus 1 over 2. This, if you put it on the calculator, 9 to the power of minus 1 over 2, you're going to get what? You're going to get 1 over 3. So you can substitute this directly by what? By 1 over 3. Now we have what? We have a very good equation. Let me just write it up. So it is 1 over 3 times 1 plus x squared over 9 to the power of minus 1 over 2. Now, using this, we will be able to expand. Why? Because our a is 1. Let us start with the expansion. We first start with the combination minus 1 over 2 to the power of 0. Remember, why did we start with 1? So that we don't have to write a. So when you are expanding, you don't need to write a in this scenario. Okay, so you don't need to write a in this scenario. So minus 1 over 2, 0 times what? Times b, x squared over 9, plus minus 1 over 2, 1 times x squared over 9, again, times b, plus minus 1 over 2, combination 2 times x squared over 9. Now, what did we say about the exponents of b? They will start from 0 and they will increase all the way to n. In this case, we cannot increase to n, so it will increase infinitely. But they want x to the power of... And I stopped it here. Why? Because look, this is to the power of 0, this is to the power of 1, and this is to the power of 2. Because with b, you start with 0 and you keep on adding 1. You keep on increasing. Okay, now anything combination 0 is 1. Okay. Anything to the power of 0 is 1. And 1 times 1 is what? It's 1. So now we have the value of the first one, which is how much? Which is 1. So 1 plus, you can get rid of it now. Minus 1 over 2 combination 1 is what? Is minus 1 over 2. Multiplied by x squared over what? Over 9 to the power of 1. So just you need to expand it, so it becomes minus x squared over how much? Over 18. So minus x squared over 18. Now you finished from this, you can get rid of it. And what do we have left? We have minus 1 over 2 combination 2. Let us put it on the calculator. So first of all, it's going to be minus 1 over 2. Then you multiply it by minus 1 over 2 minus 1. You stop because there are already two factors being multiplied, and then you put it over 2 factorial. So minus 1 over 2 times minus 1 over 2 minus 1 over 2 factorial. And you will get what? You will get an answer of 3 over 8. So now it is what? It is 3 over 8 multiplied by x squared over 9, to all of it to the power of 2. So basically 3 over 8 times x to the power of 4 over 81. Just put it on your calculator. 3 over 8 times 1 over 81. You will get what? You will get 1 over 216 x to the power of how much? X to the power of 4. So what is the answer here? Plus 1 over 216 x to the power of 4. Now we can erase all of this. And we'll be left with what? We'll be left with this over here. But we forgot something very important. If you go back to the equation, what did we forget to do? We forgot to multiply it by 1 over 3. So now you need to multiply everything by 1 over 3. What will you get now? You will get 1 over 3 minus x squared over 54, which is basically 1 over 54 times x squared, plus 1 over 216 times 1 over 3, which is 1 over 648 x to the power of 4. So this is how it's supposed to look in the final form. 1 over 3 minus 1 over 54 x squared plus 1 over 648 x to the power of 4. Now, what did they say? They said the values of x for which the expansion above is equal to this. Remember, what was the simplest form we wrote this as? 1 over 3, 1 plus x squared over 9 to the power of minus 1 over 2, right? So what do they need? They need the values of x for the expansion, or basically, what? The limitation. How do we take the limitations? Ignore everything except b. So you'll go back to our b, which in this case is x squared over 9. You will put greater than and less than. You will move 9 here, 9 here, right? So 9 less than x squared greater than 9, right? And now you have to do a radical for the full thing. After doing radical for the full thing, you will get minus 3 because always the 1 to the left is negative. So minus 3 is less than x and x is less than 3. So what is the criteria? It is minus 3 is less than x and then x is less than 3. Now we'll move on to part C. What does it say in part C? Using the expansion obtained in part A as far as the term x to the power of 4, an appropriate value of this to 4 decimal places is... Okay, so here we need to play it smart again. We have radical 1 over radical 10, which is the same as radical 1 over 10. It's what? Radical 1 is 1 over radical 10. Now, radical 10, we need to somehow make it similar to what? Similar to radical 9 plus... what was the original form? We need to make it similar to radical 1 plus x squared over 9. So let's see how we are going to do this. First of all, we know that radical 10 is what? It is radical 9 plus 1. But remember what we said? We said that always our a has to be what? Our a has to be 1. Now, why did I choose radical 9 plus 1? Because it's the one that will suit my equation the most. Why? Because I need to put something over 9. So if I did radical 9 plus 1, I will get my answer over 9. So now, we said our a needs to be equal to 1. So how do we make it equal to 1? We will take out what? We will take out the radical 9. So now it's a radical 9 times the radical 1 plus 1 over 9. Is that correct? Yes, it is correct. So that means what now? That means instead of radical 10, you will put 1 over radical 9, which is 3. So 1 over 3 times radical 1 plus 1 over 3 times radical 1 plus 1 over 9. Now, if you remember, what was the first equation that we got? The first equation that we got was 1 over what? Over 3 radical 1 plus x squared over what? Over 9. So in this scenario, we don't need to multiply anything extra because we have 1 and 1, they cancel. 3 and 3, they cancel. This one and this one cancel. This 9 and this 9 cancel. So we get what? We get that x squared is equal to 1. So x is then equal to what? X is equal to 1. So in this scenario, our x is what? Our x is 1. So what does that mean? That means instead of x over here, I will need to substitute 1. So just put it on the calculator. 1 over 3 minus 1 over 54 times 1 squared, which is 1, plus 1 over 648 times 1 to the power of 4, which is basically 1. So you put it equal to, and you will get an approximate value, which is what? Which is 0.3164. So based on solving, our approximate value is 0.3164. Now, for part D, they want us to use the calculator. So do radical 1 over 10 on the calculator. You will get what? You will get it to be approximately how much? 0.3162. So if this was 0.3164 and this is 0.3162, and they want what? They want the difference between the calculator and the approximation. So that means we'll need to subtract both sides. So what will we get? We will get 0.0002. So the final answer over here is what? Is 0.0002. We finished question number 6. Please pay attention and practice so many times because practice makes perfect. And we finished question number 6. Let's move on to question number 7. Now the questions will get a bit easier. This is very simple. You can do it on the calculator. I'm not going to explain how. You should know by now. If you don't have the option on the calculator, this is how you are supposed to do it. First thing is you're going to take each one by itself. So it's the sigma notation of 20k is equal to 1, 2k squared, then plus sigma notation of 20k is equal to 1 minus 3k, and then plus sigma notation 20k is equal to 1. We will have what? We will have 2. Now what do we do for this? You will take out anything with a variable. You will take out the number. So it will be what? 2 sigma notation 20k is equal to 1 k squared plus 20k equals to 1. You take out the minus 3. So plus minus 3, 20 sigma notation k equals to 1 k plus what? This directly, if you put it on the calculator, you will get what? You will get 40. Or you could multiply directly n by the whole number. Why? Because it does not have any variable next to it. So it's n times the constant. So in this case, it's going to be 40. Now what do? We're going to substitute k by what? by, in this case, k squared, we're going to substitute it by this, but we know that our n is equal to what? Our n is equal to 20. So you will need to substitute 20 over here. So very simply, it's going to be on the calculator, 20 times 20 plus 1 times 2 times 20 plus 1 over 6. And you will get 2870. So you can substitute this by 2870. Now, this k, you also need to substitute it with 20. So what will you get? You will get 20 times 20 plus 1 over 2, which is 210. You need to substitute 210. Now you get rid of the sigma notation. And now you need to solve. So 2 times 2870 plus minus 3 times 210 plus 40. And you will get an answer which is approximately, and not approximately, sorry, exactly 5150. Move on to question number 8. What does it say in question number 8? What is the coefficient of the x5 term in the expansion? So I'm just going to solve it really quickly. X5 term, this is our A, this is our B, right? Which one has x? In this case, A has x. So it's going to be 7 combination. We need to find the value of k in this case. 7 combination k, 2x to the power of 5, because x needs to be to the power of 5, minus 1 over 4 to the power of 2. K is always the exponent of B. In this case, it is 2. So put it on the calculator. 7 combination 2 times 2 to the power of 5 times minus 1 over 4 to the power of 2. And you will get an answer which is what? Which is 42x to the power of 5. We move on to question number 9. What does it say? The third term in ascending order. When they say third term, you will directly take x to the power of 2. If they said fourth term, you will take x to the power of 3. If they said 99th term, you will take x to the power of 98. So always you take one less of a power than the term. So in this case, they needed to be x to the power of 2. We have our A, which is 1, and our B, which is 4x. Which of them has x? In this case, B has x, so it's going to be what? It's going to be 5 combination k, which we need to find, times 1 to the power of something, and then 4x to the power of what? To the power of 2, because we need it to be to the power of 2. That means it's 1 to the power of 3, and then the k is always the value of the second exponent, meaning the exponent of b, which in this case is 2. So you need to do what? You need to do 5 combination 2 times 1 to the power of 3, which is 1, times 4 squared. So you will get 160x to the power of 2. Now we move on to question number 10. What does it say? What is the coefficient of this? So here, this is very important. We have this, and we have our A and our B, and both our A and our B have x. So how do we solve? First thing, I don't like to see any x in the denominator, so you'll have to take it up. It will be x to the power of a minus 4. Now, it's equal to what? It's equal to our A, x to the power of, let's say, 12, which is our n minus k. I'm doing this fast because you guys are supposed to know it. Times minus 1 over x to the power of k. Now remember, we don't like to see any x in the denominator, so it becomes what? It becomes minus 1x to the power of minus 1k. So you will remove all of the x, and you will be left with minus 4 is equal to 12 minus k. Move this to the other side. Minus 16 is equal to minus 2k. K is then equal to 8. So now we have what? We have the value of k. We can substitute k. Let us substitute k. It's going to be 8 here and 8 here. And then you return this back to its normal form, which is minus 1 over x. 12 minus 8 is 4. And what's left for us to put is what is the combination. So the combination is 12 combination 8, because you take the exponent of b. And now you solve. 12 combination 8 times x to the power of 4, which is x to the power of 4, minus 1 over x to the power of 8. So basically 495 x4 times 1 over x8, which is what? Which is 495 x to the power, 495 times 1 over x to the power of 4. So what is the coefficient in this case? It is 495. We move on to question number 11. What does it say? What is the constant term in the expansion of this? When they say constant term, that means x is to the power of 0. So we have our A and our B, both of them have x, so we will need to make an equation. X to the power of 0 is equal to 2x, all of it to the power of 12 minus k, times minus 1 over 2x, all of it to the power of what? To the power of k. Remember, we don't like to see anything in the denominator, so it becomes minus 1 times 2x to the power of minus 1, because We don't like to see anything in the denominator. We cancel all of the whole number and we keep the exponent. 0 is equal to 12 minus k minus k. Move this to the other side. Minus 12 is equal to minus 2k. K is then equal to 6. Okay, so now we have what? We have the value of k. And we can substitute. Right? So this becomes 12 minus 6, which is 6. This is 6. You'll return it back to its normal form, so minus 1 over 2x. And what did we forget to do? We forgot to put the combination, so let's put it now. 12 combination 6. So now we start. 12 combination 6 is 924 times 2x to the power of 6 times minus 1 over 2x to the power of 6. So this is basically 64 x to the power of 6 times 1 over 64x to the power of 6, and you cancel and cancel. And so then you will get the constant term, which is what? Which is 924. Now we move on to question number 12. Very nice. Question number 12. In expanded form, x plus 4 over 1 minus x to the power of 2. Remember what we said, we don't like to see anything in the denominator. So x plus 4, you will bring 1 minus x to the power of 2 up. It will become 1 minus x to the power of minus 2. Perfect. So now we have what? We have an exponent, which is negative. So first we will focus on expanding this. After expanding this, we will multiply it all by x plus 4. Let's first start. Remember, our a always needs to be equal to 1 in the case that our exponent is a fraction or a negative number. In this case, it's a negative number. And we already have a equal to 1. So we start. Minus 2 combination 0 times minus x, okay? Plus minus 2 combination 1 times minus x. Plus minus 2 combination 2 times what? Minus x. Then plus minus 2 combination 3 times minus x. Now we do the exponents. We always start with 0 when it comes to the b. Why did we choose 1 to be a? Because if it's 1 to the power of anything, it's going to give us 1. So it's much easier for us to deal with 1 as a. So we always start with the exponent 0 and we add 1. So 0, 1, 2, 3. So anything combination 0 is 1. Anything to the power of 0 is 1. So 1 times 1 is 1. We got what? We got the very first value, 1. You can get rid of this. Plus minus 2 combination 1 is what? Is minus 2. Minus 2 times minus x is what? Is plus 2x. So now you can get rid of this. Now, minus 2 combination 2. So it's minus 2, right? This we can write it as minus 2 times minus 2 minus 1 over 2 factorial. Times minus 2 minus 1 over 2 factorial. And we will get an answer of 3. So you can replace all of this by 3. So now it's 3 times what? Times minus x squared, which is basically 3 times x squared, which is what? 3x squared. So now you can get rid of this. Now let us do minus 2 combination 3. So we start minus 2 times minus 2 minus 1, minus 2 minus 2. We stop because there are 3 factors already being multiplied over what? Over 3 factorial. So minus 2 times minus 2 minus 1 times minus 2 minus 2 over what? Over 3 factorial, and we will get what? We will get the answer to be minus 4. So it is what? It's minus 4 times minus x to the power of 3. So minus 4 times minus x3, which is basically what? Which is basically 4x to the power of 3 plus 4x to the power of 3. Now, this is what? This is as far as we need to expand, because x to the power of 3, as far as we need to expand this one. What do we need to do now? We need to multiply all of this by what? By x plus 4. So let's start multiplying. X plus 4 plus 2x squared plus 8x plus 3x to the power of 3 plus 12x squared plus 4x to the power of 4 plus 16x to the power of 3. Do we need anything to the power of 4? No. So you can remove this right here. And now you can just like solve. So it's going to be in simplest form. After solving, it's going to be 4 plus 9x plus 14x squared plus 19x to the power of 3. So the final form is 4 plus 9x plus 14x squared plus 19x to the power of 3. So 4 plus 9x plus 14x squared plus 19x to the power of 3. We move on to question number 13. I love this question. It's very nice. This is about derivative. When they give you y and they ask you for y prime, they're asking you for the derivative. So we first start with radical 5, right? So it's radical 5 over what? Over the 6 root of 6. Perfect. Oh my bad, I forgot radical 5x. Radical 5x over the 6 root of 6. Now, what I prefer to do is to take out all of the numbers first. So if you take it out, it's going to be what? It's going to be radical 5 times radical x over what? Over the 6th root of x. So it's basically what? A radical 5 times radical x over the 6th root of x. Now, here is where, if you remember what we took before, this is to the power of 2 and this is to the power of 1. Here is where we use the exponents, okay? So you can change this very simply into what? Into x to the power of 1, so always inside over outside. That means what? This is also 1. That means you can write this as x to the power as 1 over 6. Right? Let me just erase these so we can have a bit more space. So what does it mean when we have the same base, different exponents, and they're over each other? It's the exact same thing as doing 1 over 2 minus 1 over 6, which is what? Which is 1. Which is what? Which is 1 over 3. That means I can write it all now as what? I can write it all as radical 5 times what? Times, now I need to find the derivative of what? Of x to the power of 1 over 3. Now let us find the derivative of x to the power of 1 over 3. You will bring this down. It will be 1 over 3 to the power of x 1 over 3 minus 1. What is 1 over 3 minus 1? It's minus 2 over 3 basically. Minus 2 over 3. So now it's what? It's a radical 5 times 1 over 3 times x to the power of minus 2 over 3. So very simply, it's radical 5 over 3 x, okay? Because negative means it's gonna be put down in the denominator. Of course, if it was in the numerator. And then remember that it was inside over outside. That means 2 is on the inside and 3 is on the outside. So what is the final format? It is radical 5 over 3, the cubic root of x to the power of 2. So radical 5 over 3, cubic root of x to the power of 2. We move on to question number 14. Okay, this is very easy. I've done it many times. I'm not going to explain it in details. But basically, whenever you see a constant, in this case, it means constant, and you see n on top, and you want to find the value, you will do what? You will do the n multiplied by the constant, and it's equal to what? It's equal to 20 in this case. That means the constant is equal to what? It's equal to 20 over 100, which is what? Which is 0.2. Now what will we do? We will substitute 0.2 over here. So it's going to be what? It's going to be 100, because n multiplied by 10 times 0.2, right? And you will get an answer of what? You will get an answer of 200. So our answer over here is 200. We'll move on to the next one, question number 15. What's the value of this? Again, if it's a constant and a summation, you will do the n multiplied by the constant. So in this case, 100 times 2, which is 200. We'll move on to question number 16. You can use the calculator for this. If you don't have the option of the calculator, very simple. You check the value of I and the top, and n. So from I to n, it's from 1 to 4. 1, 2, 3, and 4. That means we will have to substitute every single digit, 1, 2, 3, and 4, in this equation and add them all together. So it's going to be 1 times 2 times 1 plus 1 plus 2 times 2 times 1 plus 1 plus 3 times 3 times 1. 3 times 2 times 1. No. I messed up. You see, even I'm messing up. So 1 times 2 times 1 plus 1. Then 2 times 2 times 2 plus 1. Then 3 times 2 times 3 plus 1. Then 4 times 2 times 4 plus 1. And now you need to add everything together. So 1 times 2 times 1 plus 1. Plus 2 times 2 times 2 plus 1. Plus 3 times 2 times 3 plus 1. Plus 4 times 2 times 4 plus 1. And you will get an answer which is what? Which is equal to 70. The same if you put it on your calculator. So this is 70. Now, we move on to the next, which is question number 17. What does it say? Okay, very easy. You can do this in so many different ways. I'll just explain it really quickly. So as we said, you need to distribute the summation among them all. So it's summation 50k equals to 1. pk plus summation 50k equals to 1 qk minus summation 50k equals to 1 rk. So this, you just need to substitute the values from what they gave us. So 25 plus 30 minus 10. Put it on the calculator. And you will get an answer, which is what? You will get an answer, which is 45. We'll move on to question number 18. What does it say in question number 18? Find the derivative. Okay, if this is hard, I don't know what is, like the other questions we solved. Very simply, you will take this down. So it will become what? It will become 16x to the power of 16 minus 1. So you take down the exponent and then you subtract 1 from the exponent. So it's 16x to the power of 15. That's it. 16x to the power of 15. Now we move on to question number 19. Okay, this is not hard. It just needs a little bit of patience. So y is equal to the fourth root of x to the power of 7. What's the value of dy over dx when x is equal to 16? So they want, first of all, the derivative. Derivative, y prime, is equal to, first of all, you need to change it into fraction form. Remember what we said is fraction form? It's inside over outside. So x 7 over 4. You need to bring it down now. So 7 over 4 to the power times x to the power of 7 over 4 minus 1, which is what? Which is 3 over 4. Now, what did they say? They said, what if x is 16? So all you need to do is substitute x by 16, put it on the calculator. 7 over 4 times 16, all of it to the power of 3 over 4, and you will get the answer, which is what? Which is 14. Now, we move on to question number 20. Again, this is very easy. They're asking for y prime, which is the derivative. You move it down, so it becomes 10 times 25x to the power of 25 minus 1. So 250x to the power of 24. Now, last but not least, the last question is question 21. What is the derivative of this? When they ask you for the derivative of a whole number and no exponents, you directly put it equal to what? You put it equal to 0. So the derivative in this case is 0. Let us submit, and hopefully we don't have any mistakes. And perfect. Thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.